Okay, you are invited to follow along today. So if you want, you can start Visual Studio Code or Writer, and follow along the code that I'm going to write. If you have any questions, ask me. We will write a lot of code today. Not so many lines, but we will do a lot of discussion about the code, okay? So I think it's a good idea to follow along. Again, I record everything, so if we are too fast, if you are not completely sure whether you have understood everything, that's perfectly fine. You can rewatch it and you can always ask me questions. Yeah, with that, let's get started. We don't have any lightning talks yet, so therefore we can dive directly into the subject matter of today's lesson. And today's lesson is delegates, lambdas, and maybe some topics in C# recap that you didn't choose. I need to understand what you already know so that I do not bore you to death, okay? So, a question. What is a delegate? Imagine a student from a lower class comes to you, asks you, hey, I've heard about this concept, delegate, I didn't understand it, can you describe it to me? What would you tell this student? What is a delegate? Yeah. Did you ever write a generic delegate? Yeah? Okay. So you know a little bit. Let's try a few lines of code and let's see whether we can find out in more details what delegates really are all about. I will create a solution, a console app, okay? We will try a console app and we will name this console app Delegates and Lambdas. Delegates and lambdas. I mean, you can call it any way you like. I will call it delegates and lambdas. And then I will increase the font size to make sure that you can really see the screen properly. Is that okay like that? I guess so. I know I'm the only one in the world who likes light themes more than dark themes. So please don't be angry with me. I always get laughed at because I even run Discord in light theme. And yeah, last summer our intern, our Ferialpraktikantin, she really laughed at me when she saw that Discord was running in light theme. But I like light theme. I don't know, maybe because I'm old. Yeah. Ah, you also like light theme? I like that. Good. So let's write some very simple lines of code, okay? We have a class program here. We also know that main method, nothing special. We will have a short video about main method. Let's write a very simple function. Static int add int x int y. And we will return, guess what, x plus y. That's really trivial. That's a function. It has nothing to do with the delegate. It gets two integer parameters and returns int. That's trivial. I guess there are no questions about that, are there? No. Good. I'm relieved. And we will write another function. Static int, guess what? Subtract int x, int y. And guess what we do? X minus y. Good. I know that Visual Studio is suggesting a bunch of refactorings here. We will ignore Visual Studio for the moment. We will take a look at what Visual Studio suggests in a few minutes, okay? But currently, we write it exactly like that. Good? Good. Now, if you take a look at this method here, and if you take a look at this method here, they have something in common. They don't have the same name, as you can see it here, but they have the same return type. They have the same first parameter and the same second parameter. By the way, the names of the parameters, they do not matter. Just to make sure that you fully understand that, I will rename the parameter in the second method. It's control_RR. And we'll call it A. And the second parameter, control_RR, B. Just to make sure that we understand that it is not necessary that these parameters have the same name. The important thing are the types here. And now, for the first time, delegates come into play. A delegate, now listen closely, that's important. A delegate is a type definition for functions, like a class for an object. A class declares the type. The object is the instance of the type. You can have a lot of objects for a single class. Same is true for interfaces. An interface declares a type. All the objects that implement this interface are the instances of this interface. Understand what I mean? And the same is true for delegates. Delegates are types. They are just describing a common set of functions. And all the functions who look exactly like the delegate, they are called the instances of the delegate. So what we can write is the following. We can write delegate int mathematic operation int x int y. Now take a look. Here we have an integer return value exactly like here. Here we have an integer parameter exactly like here. Here we have an integer parameter exactly like here. So the delegate math op can be applied to this method and this method. Both methods, add and subtract, they fulfill the contract of the math op delegate. Understand what I mean? So we can write the following code. We can declare a variable math op, let's call it f like function, and we can assign add. That works. Get it? If I change the type here, for instance to float, then I get an error. Because now add does no longer fulfill the contract of the math op delegate. I have to change it back to int. Oops, not ont, int. The same is true for subtract. F equals subtract. That works too. Please note that here we do not have brackets. I do not call add. I'm assigning a pointer, a reference to the function. Understand what I mean? And now I can call f. So I can say console write line f 48 84 minus 42. This is now a subtraction because I've assigned f with a reference to the subtract method. If you want, run the app and it will return 42, of course. And if I comment out this line, this one, and I run it again, you see now we have 126. You can try it on your own PC if that's too small on the screen. Works perfectly fine. So, if you can't follow along on your laptop, if you want, I can check in this code later in the GitHub repository so that you have a written summary of this code too. Yeah, that's fine. Questions so far? Did you understand what this delegate means in this case? So next time you get asked what a delegate is, your answer could be or should be a delegate is a type definition. And all the functions who share the same parameters, return values, and all this stuff, they fulfill the contract of the delegate. They are compatible with this delegate. Got it? You might still ask yourself, okay, I understand that, but why? What's the point? Why do we need this stuff? Yeah? This will be the next step. Good. We will now maybe fold, add, and subtract, and we will write another simple function. This time, the function is a static void. It does not return any return type. And we will call it calculate and print. It will get two integers, int x, int y, and now comes the important part. It will get a delegate how to calculate the result. math op f. Now it becomes interesting because now we have written a function calculate and print where we can, let's implement it quickly, okay? Var result equals f, x, y, console write line result. That's all. I give you a second to type in the code. Now we have written a function, calculate and print, which knows how to do a calculation and how to print the result. But it doesn't know which calculation. And that's the point of delegates. I can tell the calculate and print method that it should accept any kind of method that receives an integer and a second integer as parameter and returns a result as the type of integer. So we have a very generic way of expressing what calculate and print does. You have a question?
If I call calculate and print now and I give it two ints and a lambda that uses the math of delegate also two integers.
We will take a look at that. Be patient. We will get to that in a second. And yes, you can pass a lambda, definitely. Okay, we will develop, we will walk our way through to lambdas step by step by step, okay? So what we can now do, we can now call this calculate and print. By the way, do you know this trick? Calculate and print? Yeah, if not, it's really convenient. It makes you type much, much faster. Just use the uppercase characters and press enter and you get the name of the function. Let's say 21 and add. This works because add fulfills the contract of the delegate. Add has integer, integer, integer. We are fine. We can write an add here. So let's make it this way. And if I run it again, it should write 42 two times, and that's exactly what we expect. If I do subtract, that's also possible because it fulfills the math op delegate. We can run it and we get 0 because we are currently subtracting 21 from 21. That's exactly what we expect. So far, so good. Questions? This is code that you really find today in modern C# applications. However, there are a few syntax constructs with which you can make that code much, much cleaner and smaller, and we'll take a look at that in a second, okay? There is a pattern. A very important a part of our curriculum is talking about patterns, and what we do here it is in fact, let's say, a flavor of a very well-known pattern. This here is sometimes called the strategy pattern. Why is it the strategy pattern? Because you pass in the strategy, how to calculate, as an input parameter. The original strategy pattern was based on interfaces, but you can do it with delegates too. Fine? Good? Good. Nice. Now let's try to make this code a little bit more readable. Let's make it a little bit shorter. And now comes the second part of delegates. Delegates are not just used in this context, but you can really use delegates differently. Let me show you how that works. I will take the entire add method, this one, and copy it into the clipboard. My point is that I would like to calculate and print again 21, 21, but I would now like to write the method inline. Why is it important to write the method inline? Because it's easier to read. Take a look at this line. I have to tell you a little bit about what's going on in my mind, and that's super important for any programming language. If you want to be a good programmer, now listen closely for the next 2 or 3 minutes, okay? You write code not for you. You write code for the poor guy who will maintain your code in the future. And that might not be you. You write that code, and your colleague will have to fix a bug while you are sick or absent or on holiday or whatever. You always write code for the reader. Code is way more often read than written. Code is typically written once and read dozens, hundreds, maybe thousands of times. So therefore, you always, when you write code, you always have to think about, will the future reader of my code understand my intention? Will it be easy to read? That's super important. There are only a few cases where you really have to write, for instance, the most efficient code on earth. Typically, performance optimized code is not easy to read. But in many cases, it is not that important to optimize your code to the very last point. It doesn't matter whether a certain function takes 1 nanosecond or 1.5 nanoseconds. It doesn't matter. Maybe in the next moment you're accessing a database and your database query will take 3 seconds. Why care about half a nanosecond in the other area of code? Thinking about how to write maintainable and readable code is way more important in most situations. Thinking about how to make your code easy to understand is really important. And take a look at that code. If I take, I know it's trivial code. Give me a second, okay? I want to complete the thought process and then I come back to your question. If you take a look at this line of code here, it's like writing a book. It's like writing a book like that, okay? So I don't know, she is nearly falling from the roof and the hero, he runs to her, he wants to save her, he does his best and finally he... Continue reading at page 350. This is what we do here. We want to know what's happening, but the reader has now to, oh, there is a method called add. Well, in this case, it's obvious what the add method does, but in many cases, it's not that obvious. It would be much easier if it's really a small thing, like finally he saved her, or finally she fell. Understand what I mean? It's really small. Why can't we write the code directly here so that we don't have to tell the reader of our code, take a look at page 350, because there you will find out whether somebody lived or died. Got it? You had a question?
No, it was sort of more of a statement that a lot of programmers nowadays also try not to write a lot of comments, but more try and write the code as sort of self-explanatory and much easier to read, not having to read like half a paragraph of comments over a function or something.
Very good comment. Good code needs only a little bit of documentation, but be careful. I often hear this argument from developers who hate writing documentation. As a developer, you have to write documentation, but you shouldn't write the documentation about the details of your code. I fully agree to what you say. The details of your code have to be understandable from your code. The important thing where you have to write documentation are the conceptual things. The things which cannot be found in a single line of code in a single method. The big architecture, the big picture, that is the part that you have to describe in written words. So conceptual documentation, super important. Code documentation should be sufficient to add only a few lines of documentation code because, as you said, if you have nice method names, nice variable names, if you have nicely structured code, most of the code will be self-explanatory. Yeah, I fully agree. So our goal is to add the add method directly here. So let's paste it in and let's see what C# says. Well, C# gives us now a lot of errors. However, we can change that a little bit by writing delegate here. Let's see what's happening. Okay, the integer is still not okay. Let's remove the integer. Oh, nice. By replacing the name of the method with the keyword delegate and removing the return type, we don't have to tell Visual Studio or C# what the delegate returns because it can simply take a look at the code and it will find out that int plus int is int. So this is how we can very easily put the code directly, the code of the add method, directly where it should be. Now we can make that code a little bit more smaller. So what we can do is we can, if we want, remove the caret returns. Oh yeah, that's exactly what I told you. I got a new laptop and I'm not used to the special keys here. So just in one line. Now it's easier to read. It's definitely easier to read. This delegate here is completely different from this delegate. This delegate down here is a type definition for a category of functions. This delegate up here allows us to write an anonymous function. Anonymous function means that this function doesn't have a name. That's not true. Of course, the function has a name, but the name is chosen by the compiler. Want to see that? Let's take a look. You do not need to follow along what I will do now, okay? I will just take a look. I will run a tool which is called dnspy. I think I have dnspy. Oh my god, I'm on the wrong machine. I've not yet installed dnspy. So if you want, you can follow along because you will like it. I guess you will like it. Please install dnspy. Just type in dnspy, dn like .NET. It's the .NET debugger and assembly editor. You can download it from GitHub. We don't have the best internet connection, but that is not a problem. So if you scroll down a little bit, you will find here the link to the latest release. You see it? And then you can download here the dnspy. Let's take the net core version, okay? dnspy, I will zoom it in a little bit, this one, dnspy net core Win64 for my machine. It will probably not work on Mac, but that's not a problem. I will show you what's going on. We will not use it in courses, in exams or something like this. Okay, this will take a while. So we can download it and forget about it. Because just let me quickly tell you what dnspy is all about. Do you know what ILDASM is? ILDASM. ILDASM. That's the intermediate language disassembler that's part of .NET. There is an ILASM and an ILDASM. One translates intermediate language text in intermediate language and the other way around. I have to ask something. Do you understand what I mean with intermediate language? Sure? No? Okay. Do you understand what I mean with machine language, assembler language? You know that, right? Very good. So if you compile C#, the result will not be machine language. This is not executable code that can be sent directly to a CPU, to a central processing unit, and the CPU can execute it. It's not possible. That's not what .NET is all about. .NET has a just-in-time compiler. So what C# does, it's generating intermediate language. It's generating a higher level language which is completely machine and platform agnostic. It runs everywhere. And a short time before the code is really executed, the intermediate language is then compiled to machine language, depending on the processor architecture. Yeah? So intermediate language is not processor specific, machine language is. And what dnspy does, dnspy allows you to decompile .NET code back into C# code. So if I give you my code as a .NET DLL, you can use dnspy to get the C# code out again, even if I don't give you the source code. Understand what I mean? That's a disassembler. And what I'm going to show you is, with the disassembler, what C# really generates from this anonymous function. This is what I want to show you. Yeah?
I wanted to say, if you give me your disassembled code and I assemble it again, it's not going to look exactly the same.
That's true. That's true.
C# does many, it makes the code very simple and very efficient.
It depends. If I give you a debug build, the code will look very, very similar. Not 100%, but very similar. If I give you a release build, the code will probably look a little bit different. But believe me, tools like D and SPY, they do a pretty good job. So they know what the compiler typically generates, and they try to understand which patterns are in the intermediate language and try to find the typical C# code that would lead to this kind of intermediate language. D and SPY is really, really powerful. What you can even do with D and SPY, you can rewrite the assemblies and compile them again into DLLs. So you can create manipulated DLLs. What is the important thing that you have to remember here? Never trust the DLL that you get from somebody, because it could be somebody could have tampered with it. Okay, that's important. So let's wait until D and SPY is downloaded. We will make that example later on. Just believe me, the compiler will select a very, very strange and ugly name for this method. It will not be called add anymore. It will be called some special characters, anything. We don't care. The name is chosen by the compiler. Next step. We can simplify this kind of code here. And in many programming languages, the designers of programming languages try to give us as developers tools which allow us to write code in a very concise, very compact form. They want us to use as little characters as possible to express our intention. There are other programming languages which go into the entire opposite direction. Have you heard of Go? Yeah? Go is different. Go is completely different. The language designers of Go say, no, the language has to be simple. It doesn't matter whether you write additional lines of code. Write 5 lines of code more. If we can keep the language simpler, then that's our goal. Not the shortest possible code. C# is different. C# gives us a lot of sometimes strange syntax constructs which are just there to make the code smaller and more compact. But I have to teach that to you, because if you take a look at modern C# code, they use these features all over the place. Now, let's try to apply that. What the C# language designers decided to do is they decided to get rid of the delegate keyword. They said, let's drop the delegate keyword, and instead, let's add 2 special characters. The so-called fat arrow goes to. Fat arrow. This would be the thin arrow. This is the fat arrow, okay? What you see here is a so-called lambda statement. Lambda, from the mathematical concept of lambdas, okay? But every modern programming language has a concept of lambda functions. Go, for instance, doesn't have one. They have anonymous functions, but no lambda functions. Yeah, question?
Does it make a difference if we use lambda or delegates?
Does it make a difference? You mean make a difference in terms of generated code? No. Does it make a difference for the reader? Yes. Nowadays, in 2020, with .NET 5, nobody writes delegates anymore. It's old style. If you see code that has delegates in it, I mean the first delegates, not the second one. The second one is current, yeah? But the first one, if you see code that is written with these delegate inline methods, then you know that this code has been written 10 or 15 years ago. Nobody writes that anymore. Yeah? But still, I describe it to you because it's important to understand the evolution that led to lambda functions. Then it's much easier to understand. Because the important thing here is that you have to understand that it's nothing special. We still have an add method. The only thing that changed so far is that the compiler will choose the name. It's no longer an add, it's foobar, I don't know what. We don't care. Understand? It's nothing special, it's just a function. Well, let's think a little bit more, a little bit harder about that. If you take a look at the right-hand side, whoops, sorry. If you take a look at the right-hand side, it's very short, right? We just want to add two integers. Why do we have to write return? Why do we have to write the curly braces? Answer, we don't. We can simply remove the return statement if we only have a single functionality. If we only have a single line of code, we can simply get rid of the whole return stuff. If we have multiple lines, we still need the curly braces and the return statement. But if we have a single line, we can get rid of it. Understand? Nothing special. It's just a function. The syntax is now more concise, more clear. It's clearer. It's way easier to read. Now, next step, and then we'll have a short break, okay? If we take a look at x, it's an integer. Y is an integer. Why is x and y are they integers? Well, because we told the system so. But try to follow along what I say now. It's not that easy, but I think you will make it. The compiler could be way more intelligent. The compiler could say, okay, this is the calculate and print method. Let's look up the calculate and print method. Here it is. What is the third parameter of the calculate and print method? It's mathop. It's a delegate. What is the first type of mathop? It's an integer. So here we have integer, and here we have integer. Why, as a developer, do we have to specify integer 2 times? We can make a mistake here. Why should we? Why do we have to repeat ourselves? We don't want to repeat ourselves. So the C# compiler over time became way more intelligent and is able to find out the type for you. So what you can essentially write is get rid of int, get rid of int. It's just x and y, you see? And why does the compiler still know that x is integer? Because it takes a look at the name of the method, looks up the method, takes a look at the third parameter. The parameter is a delegate. The delegate has a parameter. This is int, so the compiler can understand that x has to be an integer. There is no other option. So we, as developers, we don't have to write so much code. And now we have a lambda function. A lambda function is just a delegate. Nothing special. It's just a function, just like add. We just write less digits and letters. You had a question? You had a question? No question? Yeah.
In terms of readability, this is not optimal, no?
Why?
Because if you have like big code between the declaration of delegate and the declaration of the function, you, as a developer, if you really want to understand it, you gotta look it up again. I mean, not in our case, but if it was a more complicated method and more complicated lambda.
I fully agree. I fully agree. And this is the point where you, as the developer, have the power to decide whether you want to add the type or not. You can. C# doesn't have any problems if you write int here. It's perfectly fine. So what should go in your mind is, in your exam, for instance, will Mr. Stropek understand what I was thinking here? Will it be easy for him to read my code and understand my code? And if you think that it is good if you add the type here because it makes your code more readable, then it's perfectly fine to add it. You can choose. But if you take a look at the code and say, there are so many types and the types are really not relevant here, it's much more easy to read if we have it concise, small, compact, then get rid of the types. It's really up to you. It's not necessary to always use lambdas. Sometimes it's better to write a function like that. And there is nothing bad with that. The resulting code will be exactly the same. You as the developer, it's your code, it's your work, you can decide it. Design it. Okay? Does that answer your question?
Yeah.
Good. And of course, just like with add, we can now add any kind of calculation. We can add a subtract version, we can add a multiplication, and so on and so on. Okay, let me stop before we make a break here with just one tip, one hint. I always see that many students don't know that shortcut. It's a keyboard shortcut, but it makes me so much more productive. If you want to move lines in your code up and down, don't use the mouse, copy it, cut it, put it here, add a line. That takes so much time, okay? There is a way more intelligent way. You can put your cursor anywhere in this line and use the Alt cursor up, cursor down key. Alt cursor up moves the line up, Alt cursor down moves the line down. It is so frequent that you need that you need to shift lines. Alt cursor up or Alt cursor down. It also works perfectly fine in Visual Studio Code. So if you write HTML or TypeScript or Angular or React or Node.js or C++ or Go, it works everywhere. Yep.
Do you use a shortcut to highlight the line?
To highlight the line?
Yeah. Or do you just double click?
You mean if I want to highlight a single token?
No, the whole line.
The whole line? No, I rarely need to do that. Because if I want to move the line, I use Alt and the cursor keys. And if I need to cut a line and paste it somewhere else, I don't need to mark the line at all. I can put the cursor anywhere, put Ctrl X, and it will cut the whole line. And now you have it in the clipboard, and you can paste it wherever you need it. Yep. You don't need to mark the entire line. So Alt cursor up and Alt cursor down. Nice. We have now worked our way up from what is a delegate to anonymous functions with delegates to very simple lambdas. We will now do a short break, I think 5 minutes, right? And after the 5 minutes, we will go further steps. We will now find out what we can really do with these lambdas, okay? I hope it will be interesting, okay? So enjoy the break. 5 minutes.